We're going to use Excel to do a position analysis by using the built-in solver. In order to do that, you need to go to File, Options, Add-ins, Excel add-ins here under Manage. Go to, you want to make sure that you're clicking on the Solver add-in button right here. I also put the analysis tool pack in mine. Hit OK. And what you want to do is go in Data. You want to see that Solver is active right here. So I've created in some notes here a replica of what I want you to do. So I'm walking you through it here. Let's open this up and see. So I want to just stick with the cell spacing that I gave you. Linkage analysis and parameter. Oh, by the way, I got this from another professor. I didn't write down who it was just now. From, I think it was like San Jose State or something. I'll put it down in the credits, but I don't want to pretend like I came up with this. Let's see. I like to have the subscripts in there, so let me put the subscripts. And subscript. And I'll put our 2 in there by copying the thing. This is really probably time consuming, unnecessary, huh? 3, and then and we probably could have labeled these just the way our convention. That would have made sense. So let's see, inch. Okay, so this is giving units 10, 3, 12, and 8 right here. And I am making all of those yellow as inputs. Put some blocks around it, make that clear right there. And then this is radians here in B9 and degrees right here. I'll steal this just so that I didn't want to do the subscripts again. And I will make some thetas right there. So that's theta. Oh, that should be theta 2. And that should be theta 3, and that should be theta 4. 3, and no, that's 3. And this is 4. And let's see here. I'm saying this is going to be equals to 2 times pi divided by 3, which is actually degrees, should be here. So it's 120 degrees. And I'm making these as inputs of 1 and 2. I'm going to give them a couple decimal places here. Oh, not that many. And I'm going to make these as, well, I decided that I go that green right there. All right, so now we have that section in here. Now I'm going to make this right up here, plot coordinates, upper leg, vertex, capital X, capital Y, vertex is 1, 2, and 3. Again, I should probably label these like what we've been using here, but that's the way I have it right now. So it probably would make a lot more sense to calculate this to make these match what our conventions. All right, this is lower leg. I'll continue with this. Vertex. Of course, I just could have vertex. I could have copied all this stuff up. Well, copy that right there. And that should be 3. And I guess I put an asterisk next to it to remind myself that that's going to be, that's going to change right there. Okay, let's see, I'll format afterwards. Right here, I'm going to take, I'm saying B5, which makes sense right there. We're going to multiply that crank leg by the cosine of B10, which is the input. Makes sense. We're going to calculate the y component there by taking that r, which is the crank, and multiplying it by the sine of this guy right here. Great. And I'm going to find where 3 would be based on this cell in the x plus B6, this one, times the cosine of this angle right here. Okay. Yeah. And I would also find the y component of that point, which that's going to be point B, is what we've been calling it. Excuse me, whoops. I'm going to add to that the sine, that times the sine of that angle right here. Coming down here, okay, so this cell I'm skipping down here is just going to be equal to B4. Okay, that makes sense. And y, right? So this is what we find, point 4, that's what we've been calling like O4, is that connection point. And then right here, we're going to go the opposite direction. We're going to go this guy plus, did I say? Yep. Okay, so the next direction, we're going to take, yep, okay, that. So we're going to use that last leg times the cosine of this angle, right? B12, yep. And then equal to this plus the sine of, nope. That times the sine of that. Yes, okay. Now, if these were the correct angles right here, they would have this 3 right here and this 3 would have been equal to each other. So down here, I'm going to write the difference, right, and then the residual. And so the difference here is going to be F6, that guy, minus F10, which is that guy. Boom. And then, okay, so it's just going to be the same thing right here. It's going to be G6 minus G10. And then the residual is going to be the square root of this squared plus this squared. By the way, we didn't necessarily have to do this, but that's okay. It's very similar to what gets done in the MATLAB. So I'll just do a little bit of formatting here. Not 100% necessary, but it's good to make these things look good. I think all of these are in the center, and I might make these in the center right there, and put some stuff around it, put some borders around it. That's great. Now I want to plot some things. So I would like to plot these legs. Okay, so I'm going to make it look like this right here in the instructions that I have. If I can find it right there. Right here. All right, so the instructions that I posted make it look like that. All right, so I'm going to first, let me plot one thing at a time and then I'll add them in. So I'm going to plot links, this first link right there. So I'll just grab a hold of those and insert this right here. It's very boring. Oh, and it by default it went to the wrong spot. So let me click on that, and I'm going to shift these things around a little bit. I believe I want that and that. Did that do it right? I think I have them backwards, actually. Sorry. Right there and right here. It's probably a lot easier way to do this. That's not looking good. Oh, no. Okay, no, that's fine. Yeah, I had it right before. My bad. Boom, boom. All right, cool. And we'll go add to this, and we'll add from here to here, and add from here to here. So we're just one link at a time. All right, so then you see that we've added in that coupler right in there, and then we'll add in over here, we'll add in this leg to this leg. Boom. Okay. And maybe we want to do some matching. We don't have to match the thing if we don't want to, but if you wanted to, we could format the data series here. It's not showing up. There you go. And I could just make the line red if I wanted to, and make the marker. We could built in. I like them round. I like round. Why not? Round's a funny color. You can make the fill color there. You can make it any color you want. It doesn't matter. They actually overlay each other. This guy right here for the line. Did that go in? Yeah, solid line. And I think I made him blue. Oh, that's making the thing around. There it is. Yeah, it's actually, that was going around the marker. Made him blue, and I think I made him purple. This really doesn't matter. Okay, so I can get rid of that and get rid of here, and bring this over to there. We don't need a chart title. And truth be told, here's something I just can't stand. I hate these things. It's just a pet peeve. I don't like the border around these when we print them out. So that's pretty close to what we were looking like before. Maybe that made this thing a little smaller. And as we've seen in other videos, we might want to change what the axis increments are to make them square. If that was going to be true for this one right here, we'd probably have to squish it down a little bit. Yeah, something like that. We don't have to. But something if we wanted to do. And okay, so here's the crux of what we're doing. We go up to data and go to solve, and we want to set the objective, which in this case is going to be equal to the residual. We want to set it to a value of 0 by changing these two cells. We hit solve right there. Boom. We will see, if we move this over, that we have the necessary angles. So what would happen if we were to, this is the setup that we had in, that came from the author of this Excel spreadsheet. What if we wanted to do instead use one that we've previously done in an example? So we did an example of the crank slider, right? Or excuse me, the rocker, the 4-bar that looks like this right here. We had, okay, so these are going to be millimeters and millimeters. I just want to fix it, right? I really should have copied this over to a new sheet, but that's okay. So we'll go 100 is probably going to be all messed up right there. Yeah. and that's 40 and 120 and 80, and for here we probably could have made this thing backwards, right? We could have gone, this was the input right here, and make that 40 degrees, and make this one equal to radians of that right there, right? So that's the input. Boom. Okay, so now you can see we got this thing's really messed up. So let's do that thing again here, though. The data solver, and that's okay. We got that all set up. I think we can just hit solve again, and look what we got. As an answer that we previously got to this, we found that it was 20 and 57. So look right here, 20 and 57. Okay. What we might want to do now, though, is to that was because it was close enough. The original guess was close enough to our approximation. What if we know that this thing is going to go negative down here in the other configuration? So I'm going to go ahead and guess some values of like -1 and like -1. Boom and boom, maybe right in there. Okay, and let's see what the solver does. Solver, all the things are the same. Boom. Okay, it went to here, so it went back to the 1. So let's see if I could fix this thing out. -1, and maybe make this 2, or maybe make it 4. Boom. Okay, so let's see what happens with this guess right here. Solver, and oh, it's really messing with me now. Okay, so I didn't try this out. So -1. And what did I say, 4 there? How about we make it 3? 3.5. I want to make it closer to what the thing is. So how about -1.5? Okay, let's try it. Let's see. And solve. Boom. It's going to the same one over and over again. So let me see what I did in the previous thing. I don't remember how I got those to work. Well, anyway, hopefully you get the idea here. -1. So what does it turn out to be here? -1 and -1.7. -1.7. Is that right? All right, so let's see as a solver. Will it work? Will it go to it? Will it jump to it? Oh, this might be the one. Evolutionary, simple. Okay, we might need to try that. I think I forgot. Yep, okay. So let me try this again. -1 and -1.7. All right, and solver down to here, make unconstrained variables non-negative. Oh, that's what we want to do. That was the key. I forgot about that. That was an important thing here. Nope, there you go. All right, so there's the solving thing right there. So we could have probably picked that -1 and the -2 or whatever the hell it was before, and as long as that was unclicked, we could have put it in and come up with that alternate solution. So that's the means by which we've done a numeric Excel approximation. And we'll see that we can also do this in MATLAB. So that's it. Thank you.